Hey everybody, so in 6.3 we're going to be talking about something called indirect proofs. So all the proofs you've done up to now are technically called direct proofs, right? They have a clear start point, middle, and end point. Indirect proofs are done in almost like a backwards order. So for an indirect proof, we actually begin by assuming temporarily that the desired conclusion is not true. So we assume that whatever we are trying to prove is not true, is inaccurate. Then you reason logically until you reach a contradiction of the hypothesis or some other known fact. So we take a look at what we're being asked to prove, and we want to assume that it is inaccurate, that it is not true. Then we basically use all things that we've learned, reason logically, definitions, theorems, etc., until we contradict our hypothesis. And our hypothesis has to be correct. So if you've contradicted your hypothesis, then something has gone wrong, and our temporary assumption has to be impossible. So because you reach a contradiction, you know the temporary assumption is impossible, and your desired conclusion must be true. So we have three main steps on how to write an indirect proof. First, assume temporarily that the conclusion is not true. Then you reason logically until you reach a contradiction of a known fact, and that known fact is typically the hypothesis. So you contradict the hypothesis. You then point out that the temporary assumption must be false, and therefore that the conclusion must be true. So really the best way to see this is just with some examples. So we're going to take a look at two examples here. And indirect proofs are written in paragraph proof format. So for example 1, we are given that n is an integer and n squared is even. So these things must be true. N must be an integer and n squared must be even. We're going to prove, therefore, n is an integer and n squared must be even, yeah. We're going to try to prove that n is even. But to do this as an indirect proof, we're actually basically going to show that n can't be odd. It's impossible for n to not be odd, and if n is not odd, it therefore must be even. And that's that indirect proof format. So our first step is to assume temporarily that the conclusion is not true. So our conclusion is that n is even. So we are going to temporarily assume that that is not true. So our first thing we're going to do is start there, and we are going to assume that n is not even. So we're assuming that our conclusion is not true. Well, if n's not even, then it must be odd, right? So we're going to assume that n is not even. Then that means that n is odd. So then n is odd. And if n is odd, we have to think about what would happen. Well, if n is odd and an integer, and we're dealing with an n squared, well, let's see what happens if n is odd in that situation. So then n is odd, and we know that n squared, so n squared equals n times n, right? So that means if n is odd, then n squared has to be an odd number times another odd number. But a rule of mathematics is that an odd number times an odd number is still another odd number. So that's going to equal an odd number, right? 3 times 5 is 15. 7 times 11 is 77. An odd times an odd is still odd. Well, this contradicts our given, right? If n squared is odd, that contradicts our hypothesis that n squared is even. And that can't happen. We can't contradict our hypothesis. Our hypothesis must be true. So if we have that n squared is odd, we would then say this contradicts the given information that n squared is even. Therefore, the temporary assumption that n squared, or I'm sorry, that n is not even must be false. Therefore, n must be even. So we're basically completing a proof by showing it can't be something else. So it's doing it in literally an indirect manner. Okay, so that's our basic format for that. Assume that your conclusion is not true. What does that then tell you? What can you then state from there? Show that it contradicts the given information, and therefore basically state that that's impossible. And the original conclusion must be true. All right, let's look at that with another one. Example 2, we are given that we have parallelogram XYZW and that the measure of angle X is 80 degrees. We're going to prove that parallelogram XYZW is not a triangle. So we are going to prove that it is not a triangle with an indirect proof. So first step is to temporarily assume that the conclusion is not true. So if this is not true, then we must conclude that it is in fact a rectangle. Or not conclude, assume, I'm sorry. So assume temporarily that parallelogram XYZW is a rectangle. So we're assuming that our conclusion is not true. Well, then think about what that means. If parallelogram XYZW is a rectangle, what must it have? Well, a rectangle has 4 right angles. Well, so if it has 4 right angles, then angle X would have to be a right angle, wouldn't it? But wait, that contradicts our given that X is 80 degrees. So that's the route we're going to go with this. So again, what do you know that because it's a rectangle? Because it's a rectangle, we know we're going to have 4 right angles. So then parallelogram XYZW has 4 right angles. That is what a rectangle has. But this contradicts the given information that the measure of angle X is 80 degrees. So that angle X measures, or has a measure of, however you want to phrase that, Therefore, the temporary assumption is false, and parallelogram X, Y, Z, W is not a rectangle. And there are a few more examples of this in your textbook if you need some additional help or additional practice with this, okay? And there's just a couple different indirect proofs for your homework tonight, so not too much. And let me know if you guys need any help. Have a great day.